So in this video, I'm going to go over the geometric sequences in series. We're going to derive the formula for the sum of the finite geometric series, and we're going to use it to solve problems. So when we're given a set of numbers, you can analyze the data and determine if the set fits the criteria for a geometric series, and then find the sum of the finite series, okay? So we're going to talk about what this is. So when we're talking about geometric series sequences, y'all, that basically means a set of numbers that has a pattern, okay? So this is geometric. Let's see if my pen's going to write. Geometric sequence is a sequence in which each term after the first is found by either multiplying or dividing the previous term by a constant called the common ratio or constant ratio. You could also call this the constant ratio. Okay? So if you know the term in the common ratio, you can find the recursive formula. So the recursive formula is the formula that we're going to use to find the next however many terms, okay? So when you need to find, when you're given the first term and then you find the ratio and you have to find subsequent terms, that's what the recursive formula is used for. And then the explicit formula is used when we want to find a specific term in the series. So say we want to find the 5th term or the 10th term, okay? So when we're talking about the recursive formula, A1 is the first term in the series. Okay, so that's what A1 is. And when we're looking at this formula A to the N, which means it's some term in there, I'm going to multiply the ratio times each term in order, okay? So when we find the ratio, we call that the common ratio, right? Okay, so to do that, what we're going to do is we're going to take the second term and we're going to divide it by the first term. And this is represented right here, okay? So now the explicit formula is when we want to find a specific number in the series. So say we want to find the 10th term or the 20th term or whatever, then we would use this formula right here, okay, when we want to find a specific term. We use a recursive formula when we find each subsequent term, and we use the explicit formula when we want to find a specific number in the series. So it says find the next terms in the sequence and then find the requested terms. So first of all, let's find the ratio. So to do the ratio, remember once again, we're going to do the first term. And we're going to divide, sorry, not the first term, my bad. The second term. And we're going to divide it by what? The first term. Okay. So the second term here is 6 and the first term is 3. So our common ratio is going to be what? 2. So the other things we need to know for this are the first term, which is our a to the a sub 1. Okay. That's going to be our first term, which is the 3. Is that term right there, right? And then ultimately we're going to need to know how many terms we're looking for, and that n is always going to be that 10 right there, okay? So when we're using the recursive formula, this is how we're going to find every subsequent term. So when we use the recursive formula, the formula is a to the n is equal to the ratio times a to the n minus 1. So what does that really mean? So that means basically I'm going to multiply the ratio times every previous term to get the next term. So I got 3 is my first term, right? So what did we multiply by 3? 3 by, well, let's just actually back it up here a second. We're going to multiply the ratio. So the ratio was this 2 right here. So we're going to multiply 2 times the 3, and that's how we got the 6. So as we kept going through this, we would multiply the 6 times the 2 times the 6, the 2 times the 12, the 2 times the 24 would be how we're going to get our next term. So this term right here is going to be 2 times 24, which is 48. This term here is going to be 2 times 48, which is going to be what? 96. This term right here is going to be 2 times 96, which is 192, okay? So that's how we use the recursive formula to determine what the next number is in the sequence. So this was 48 and 96 and 192. The explicit formula is the formula we use to find a specific term, okay? So when we're looking for a specific term, and in this case, we're looking for the 10th term. So what we're going to do again is I'm going to write this formula. So this is a to the 10th, okay? So that's going to be, we're going to now take our first term. So I'm going to say a1 times our ratio to the n minus 1. That's how we're going to get this, the 10th term, okay? So we're going to take our first term, which we have up here, a to the 3, that's 3. And then we're going to take our ratio, which was 2, and we're going to multiply that by the 10 minus 1. So this is going to be 3 times 2 to the 9th. So this is going to be 3 times 512, which is going to be equal to 1,536, 1,536. So that is this term right here. So a to the 10th is 1,536. Got it? Okay, so we're going to do the same thing for the next one. Okay, so I'm going to, again, solve for my ratio first. So I'm going to take my second term, and I'm going to divide it by my first term. So my ratio is going to be -3. My first term is going to be a 2, and down here again, my n, when I go to solve it, is going to be 16, okay? So the recursive formula, again, we're going to take our ratio, which is -3, and we're going to multiply it by every term. So in this case, we're looking for these next 3 terms here, right? So we're going to do -3 times -54. That's going to be equal to 162. So that's what goes up here. Then we're going to do -3 times 162. That's going to give me -486. And then we're going to do, okay, -3 times -486. And that's going to give me 1,458. Positive 1,458. So again, that's our recursive formula. We're using that to get our next 3 terms, okay? So the explicit formula, again, this is the one where we're going to take our a1 times our ratio and our n minus 1, okay? So our a1 is 2, our ratio was -3, and we're going to take that again to the 16 minus 1 power. Right? So this is going to be 2 to the -3 to the 15th power. So do the -3 to the 15th power first, and then multiply that by 2. So this is going to be 2 times, what I got was -14,384,000, no, 348. My bad. 348,000. 907, and then I'm going to multiply that by 2, so my final answer over here is going to be -28,697,814. So now what I'd like you guys to do is do the next 2 terms, the U tries, okay? So pause me here, come back when you're done. So here again, we got our ratio. So we're going to do 3 divided by 1, that's 3. A1 is equal to 1, and our n down there at the bottom is 24. So to solve for these next 3 terms here, what are we going to do? We're going to do 27 times 3. That's going to be 81. 81 times 3. That's going to be 243. And then this last blank is going to be 243 times 3, and that's going to be equal to 729. That's our recursive formula, right? Now we're going to use our explicit formula. So we're going to again take our a1 times our ratio to the n minus 1 power, right? So a1 is equal to 1. We've got 3. And 24 minus 1. So this is going to be 1 times 3 to the 23rd power. So it's really going to be 3 to the 23rd power, right? So this one's going to be 883. All right, this one, again, find our ratio. So we're going to do 20 divided by 40, because remember, taking the second term, dividing it by the first term. So our ratio is going to be 1/2. Our A1 is going to be 40. And our n down there at the bottom is going to be 12. So when we're using our recursive formula here, again, remember, we're going to do 1/2 of 10. So that's 5. We're going to do 1/2 of 5. So that's 2.5. And we're going to do 1/2 of 2.5. So that's going to be 1.25. Okay. Our explicit formula, again, we're going to do A1 times R to the n minus 1. So the 40, and we got 1/2 is our ratio, and we're doing 12 minus 1, right? So this is going to be 40, 1/2 to the 11th power. So when I do that, I'm going to multiply 40 times, I got 0.01953,125. When I multiply 40 by that, sorry. This was the answer, so my bad, y'all. That was the answer when I multiplied 40 times that. And this is equal, by the way, if you push math 1 to 5 over 256. So basically what this is this is the 12th term in the series of these numbers that start with 40 and has a common ratio of 1/2. Okay? So the next one says, given that a sequence is a geometric, find the 5th term if the 10th term is 98,415 and the common ratio is 3. So this now tells us that we got the 10th term. So this is going to be a to the 10th is equal to 98,415, right? Our ratio is equal to 3. And guess what we don't have? We don't have the first term. So that's what we're going to actually have to solve for first. Then we can find the 5th term. So what I'm going to do is I'm going to write the formula for a to the 10th. That would be a to the first times the ratio, and then we're going to do 10 minus 1, right? So the ratio, so we're going to plug in these numbers we have. We have this number here, so that's 98,415, right? We don't have the a to the first, but we do have the ratio. So this is going to be 3, and then 10 minus 1 is 9. So this is going to be 98,415 is equal to a to the first, and then when we do 3 to the 9th here, that's going to be 19,683. So how do we get rid of a number that's being multiplied? We divide it, right? This is 19,683 divided on both sides. Whoops. So once I do that, I get that A1 is equal to 5. All right, now that we have A1, we can find the 5th term. So we want to find a to the 5 now, right? So we're going to take our first term, which was so we're going to do a to the first times r to the n minus 1, right? So we're going to do our first term, which was 5, and our ratio, which was 3, and we're going to do that to the 5 minus 1 power, right? So that's going to be 5, 3 to the 4th power. So 3 to the 4th is 81. So this is going to be 405. So a to the 5th. So the 5th number in the sequence, when you have the first number that's 5 and a common ratio of 3, is going to be 405. All right, this one says given, so go ahead and do this one and come back to me when you're done. So the first term, a to the first, is going to be 1536. Our ratio is equal to 1/2, and n equals 7. So this time we've got the first term, so all we have to do is plug this into the formula, right? So we want a to the 7th, so we're going to take a to the first times our ratio and n minus 1. So again, this is 1536, our ratio is 1/2, and we're going to do 7 minus 1. So it's going to be 1536 and 1/2 to the 6th power. So do the 1/2 to the 6th power first, and then multiply that by the 1536. and you should get that a to the 7th is equal to 24. This one says Samantha's dad gave her a push on the swing, and at her highest point she is 5 feet off the ground. If he doesn't give her another push, each progressive swing will be 85% of the height of the previous swing. How would you find the height of the next 3 swings? Use the information to write a formula and find the height of 10th swing. So first of all, A1 is going to be 5 feet, right? Our ratio is going to be that 0.85. Now it's asking us to find the height of the next 3 swings, so we're going to use our recursive formula for that. So we're going to do 5, that's our first number, and then our second number is going to be 5 times 0.85, right? That's going to be equal to 4.25. Our next number is going to be 4.25 times, again, our 0.85, right? That's going to be equal to 6125. Sorry, 3.6125. And our last number is going to be 3.6125, again, times our 0.85. So this one is going to be, our last term is going to be 3.070625. Okay, so these are our next 3 terms. 1, 2, 3. Okay. Then it asks us to find the 10th term in the sequence. Okay. So this time we're going to go a to the 10. We're going to take our first term, which was 5, times our ratio, which is 0.85, and we're going to subtract 10 minus 1. So this is going to be 5 times 0.85 to the 9th power, right? So when we do that, we get 1.158 feet. Now if it asks us for this in inches, we would multiply this number times 12, right? So 1.158 times 12 inches, because there's 12 inches in a foot, and that would give us 13.9 inches. So here it says you can also find the sum of a finite geometric series. That's a series that has an end to a certain term, and the sum of an infinite geometric series, and that's a series that goes on forever. So here again, remember that our a sub 1 is going to be our first term, right? And our r is going to be our common ratio, and we're going to get this the same way we've been getting it. So we're going to do our second term divided by our first term, and then the n is going to be the number of terms that we're going to. So if we're going to the 10th term, then the n would be 10. So this is an actual term that we're talking about. So when we do this, it says find the sum of the following series to the 5th term. Okay, so this formula, again, this means we're going to add 1 through 5, the first 5 terms together. That's what this means. So the first thing we want to talk about is what is a, our first term. So that's going to be our 4. That's that term right there. Then our ratio, the way we find that is the way we've been finding it. So we're going to take our second term and divide it by our first term, and that's going to give us 5. And then it's asking us about the 5th term here. So that n is going to be equal to 5. So our formula for this is S, the sum of the first 5 terms is equal to, and what we're going to do is we're going to do our A1 times 1 minus our ratio to the nth power over 1 minus our ratio. So when we put our numbers in here, we're going to put 4 in here for A sub 1, which is, again, our first term. Then 1 minus our ratio, which is 5, to the 5th power, because that was our n, and then we're doing that 1 over 5 again, okay? So when we do this, we're going to do 4 times 1 minus, we're going to do 5 to the 5th, so that's going to be 3125, and then this is going to be minus 4, right? So when we subtract 3125 from 1, we're going to get 4 times negative 3124, and this is going to be over negative 4. So I really want y'all to watch me here, because what I'm going to do is I'm going to cancel some things out. So notice I can cancel these negatives out, right, because a negative divided by a negative is a positive. I can also cancel out these 4's here. So when we talk about the summation of our first 5 terms, our answer is going to be 3,124. Okay? Now this problem says now find the sum of the infinite series. So once again, this is going to be a different formula. So we're going to use this formula this time, where we're going to do our first term divided by 1 minus our ratio. Okay? So our first term is still 4. Our ratio was, if you remember, 20 divided by 4, which was 5. Okay? So here, when we're trying to find this one, we're going to do our 4 divided by 1 minus 5. So that's going to be 4 divided by negative 4, which is negative 1. Okay? All right, so go ahead and do this. You try to come back to me when you're done. So here again, this one's asking us, the first part here is asking us to find the sum of the finite, right? So our first term is going to be a 2. Our ratio, we're going to divide 6 by 2, which is going to give us 3. And our n is going to be 8. So here again, we're just going to populate this formula. The summation of the first 8 terms is going to be equal to our first term times 1 minus the ratio to the 8th power, right? Over 1 minus our ratio. Okay, so we're going to go ahead and fill this formula. So this is going to be 2 times 1 minus 3 to the 8th power over 1 minus 3. Okay, so this is going to be equal to 2 times 1 minus 6561 over a negative 2. So here again we got 2, and when we subtract the 6561 from the 1, we're going to get 65 negative 6560. Okay, and that's again over that negative 2. So what you should be noticing here again is that cancels that negative over negative, and that 2 over that 2. So when we talk about the summation of our first 8 terms, this is going to be 6,560. Okay? Now the infinite sum again is going to be a different formula. So we're going to go s to the n here, and this time we're going to take our first term, and we're going to divide it by 1 minus our ratio, which is 3 again. So this is going to be 2 over negative 2. So this answer is going to be negative 1. Okay. Now, the answer is not always going to be negative 1, so don't assume that.